In Math 1 and Math 2, we talked about recursive patterns. In Math 1, we talked about them for linear functions, exponential functions, and then when we moved to Math 2, we discussed them for quadratic functions. So we're going to quickly look at that pattern for polynomials where the power for the polynomial is higher than 2. So we're going to look at x cubed. So I'm going to plug in -4, etc. into x cubed, which is going to get me -64, -27, -8, -101, 8, 27, and 64. Now, when we had linear functions, we found that the first difference was constant. That's the definition of a line. It's got a constant rate of change. And exponentials, their rate of difference is always exponential. The exponential pattern repeats itself no matter how far you go out looking at the differences. And when we did quadratic differences, we found that the first difference was linear, which made the second difference constant. So let's see what pattern we see when we have an x cubed function, a cubic function. So my difference from -64 to -27 is +37, +19, +7, +1, +1, +7, +19, and +37. When I'm looking at these numbers, I do see a pattern. I've got these 1s happening, these 7s, these 19s, these 37s. So something is happening. But let's go check out the second difference. Since with quadratics, the second difference was the constant. That was what allowed us to see that the first difference was a linear function. So from 37 to 19, I go down 18, down 12, down 6, 0, 6, 12, 18. So in this case, these numbers are not constant. They are also changing. So the second difference is not a constant. So let's go out one more time. And when we do that, we can actually see that the third difference is a constant. So given that this difference is a constant difference, that means our next one over is a linear difference. Because it has a slope. It has a slope of 6, so we have a linear, which means one step over we have a quadratic. Which means if I'm going to write the recursive equation for a cubic function, I'm going to have an f of starting equals a value. And then my f of n equals f of n minus 1. This equation that goes here is going to be a quadratic equation. And it turns out that this pattern continues. So if I were to look at f of x equals x to the 4th, it would turn out that the first difference here would be, cubic, and for f of x equals x to the 5th, the first difference would be quartic, etc. Which also means that I'm going to have to go all the way out to the 4th difference here to see the constant, and the 5th difference here to see the constant. So my power equals the number of differences needed to see a constant rate of change.